Hey guys, and welcome back to the MATLAB environment. First of all, big sorry for taking too long for this video. I'm quite busy at the moment, and I've also prepared a finite element analysis challenge, which will be launched in a few days, which is a 3-part series about finite element analysis on a wing, and where you can win some prizes, so stay tuned. So that's the excuse for taking too long. So let's get started. So today's video is about vector indexing. And in the first 2 lines you can already see that I've created 2 vectors, and that's very straightforward, and I want to show you that we cannot access the 0th and the 7th element, because in MATLAB you start counting at 1, so that's not possible, as you can see. And if I uncomment the second one, it's also out of bounds because we have 6 elements, as can be seen here, and we want to access the 7th one, so that's not possible. So jumping straight to extracting a subvector, we have a subvector 1. It contains the second vector, but only the values from 2 to the end. So it should give us 2 and 3. So let's just quickly check this, and this is true. So I hope this is clear. If not, feel free to post a comment, and I will make sure to answer you. We can also create a subvector by taking the first vector and take the first, second, and third element, and then concatenate it into a new vector, which is called subvect2. It's quite inefficient, but it will look like this. Or we can be a little bit faster and say, hey, please take first vec and use the elements 1 to 3. It will give us the same, as can be seen here. In the last example, we can also use several vectors. So it's subvect2 and first vec, take some values from them and then just concatenate it into a new vector. And it would look like this. So I hope that is clear. Jumping to section 3. How to work with subvectors and element-wise multiplication. So we create a subvector 4, take the subvector 2 and multiply each element by 5. That will look like this, so that, as you can remember, the subvec 1 element, it was a 1, this was a 2, and this was a 3. So it multiplied each element respectively by 5. Also very straightforward, very easy operation. And the next example, we create a rand3 matrix, which is a 3 by 3 matrix with random values. And we can create, these are matrices, so if I print it out, you can see it's 3 by 3. And if I, let's uncomment this, if I want to create a matrix into a vector, I simply say, please create a new vector C and take every value of B and concatenate it into like a vector, as you can see here. That's very easy and straightforward. In the next example, we can also index to the end. That's also very easy. If you say, hey, I want to go from 1 to the end, or it's kind of useless, as I have put it here in the comments, because 1 to the end, you can also just say take every element with a colon. So you can just write this, or leave it like this. Let's say you want to say, hey, I want to 5th to the last element, then you can write it like this. This works as well. So if you want to adapt the vector programmatically, we take the first vector, put it out, this is this vector, and we say, please substitute the first 4 values with the values from A, which is also 1 to 4, and multiply these values from A by 10, and after you have multiplied these values from the A matrix by 10, please put them in the places as I told you. So as can be seen here, the first 4 values are multiplied by 10 from the A matrix and put inside of that. So if you open A and see the first vector is 0.19 times 10 is this value, 0.72 times 10 is this value, 0.72 again is this value, and 0.87 is this value, and 5 and 6 are unaffected, as you can see right here. So let's close this and move on to section 7, which is indexing with logic. So we create a C vector, which is rand. It's kind of useless, this line, because I'm not using it. So we're just using A and B, and we want to see if it gives us a logical array, as you can see here, and should just print us the matrix. So let me just explain it step by step what we do. Let's uncomment this first. So we compare A and B, and we want to see, we want to compare the values. So we say A less B. So according to the logical array, this value, like in the first row, the last element is, there's A smaller than B. We can see B is 0.83 and a is 0.40, which is correct, and the same goes with the other values, which you can check by yourself. So if we now want to print out the values that are true and are affected by this condition, we can say please print a matrix, and this is the matrix A with the index values that we have calculated here with a logical array. Then it would give us the values that we have just seen. Here if we say A, it gives us these values that you have just seen and which fulfill this condition, so to speak. In the bonus section we have a test vector, and we now use this condition, and I explain you what it does. So we have a test vector here, and we first want to test if the values are less than 25. That's true for the first 3 numbers. The other numbers are bigger than 25, but we also want to see if the modulus of these values equals 0 if I divide the number by 2. So modulus means if I say 10 mod 2, that means please divide 10 by 2 and give me the remainder. And this is the function mod. And if this rest that we get from multiplication is equal to 0, it fulfills the condition. So if we divide 10 by 2, it gives us 5 with a remainder of 0, and it is less than 25. So the whole condition is fulfilled, and it gives us a 1 at this case. The same is true for 20, but it's not true for 7 and the other values. If you divide 7 by 2, you get 3 with a remainder of 1. So the second condition is not fulfilled, and you will get a 0 at this place. So I hope this was clear. I've put some more comments down below. If you have any questions, comments, thoughts, feel free to put them down in the comments. I'm happy to answer them, and I would say see you in the next one.